Hello, today's video is going to be devoted to graphing average costs in the short run and the long run. It will follow the second half of chapter 8 in the textbook. And before we begin, a quick recap of what I talked about in the previous video, firms in the short run. So in the short run, we assume that capital is fixed and labor is variable, and thus because capital is fixed, the cost of renting capital is a fixed cost. It does not depend on the amount of production, whereas the cost of labor is going to be a variable cost. It will vary with the amount that the firm chooses to produce. From time to time, the amount of capital can be adjusted, and this is when we move from the short run into the long run. You rent capital for a fixed amount of time. Once the time elapses, you can rent more or less capital. And so in the long run, both fixed and variable, both the amount of capital and the amount of labor change, and thus there are no fixed costs at all. And so in today's video, we're going to do two things. First of all, we're going to look at the components of the short run average costs, and we're going to graph short run average costs. And once we complete that task, we'll switch to graphing long run average costs. So let's begin with the short run average costs. And I'm going to work on the build up on the example that I developed in the previous video, but in today's video it's going to be a little bit more complicated. So in the short run, we can write down the following accounting equality. Total costs are fixed costs or plus variable costs. And if we take it down into the abbreviation form, we can write that TC equals FC plus VC. The next thing to do to move from totals to averages is to divide both sides of this equation by output, by Q. So take total cost divided by output. It will be equal fixed cost divided by output plus variable cost divided by output. In terms of the averages, that would mean average cost equals average fixed cost plus average variable cost. And we can write it down explicitly as that equation. So we just took the accounting identity and divided it by output to switch from totals to averages. Now let's look at the table, and actually it's the table from the previous video. It's just that I grouped costs somewhat differently for convenience. So we're gonna extend our output. I think we had it till 4 last time, so now we'll have it till 7, and so the total costs will be in the first row, and then we'll divide those total costs by the number of units produced. You should be familiar with that exercise by now. And then we'll split the total cost into fixed cost and variable cost, and for fixed cost we'll calculate the averages, and for the variable cost we'll calculate the averages as well. And recall that to find out the fixed cost, you need to see what the total cost is when no units are produced. So total costs of 0 equal fixed costs, and variable costs equal total costs minus fixed costs, and they will be increasing as well. So let's graph fixed costs first and see how those behave. Then let's graph variable costs, and then let's graph the average cost as well. Go into fixed costs. In this example, fixed costs are at the level of $90, and so this amount does not change with the amount of output, so it's just going to be a straight line, straight horizontal line on the graph. And that's going to be this blue line right here. That simply means that no matter how much you produce, your fixed costs are fixed at the level of $90. When it comes to average fixed cost, we take this $90 and we divide it by the number of units produced. How much per unit? So if we have just 1 unit produced, then all the fixed costs are attributed to that unit, and so that's going to be at the same level of 90. When we produce 2 units, these fixed costs of 90 have to divide it between 2 units, so per unit it's just going to be 45. And the more units we produce, the cost attributed to each unit is going to be smaller and smaller and smaller. And so this red curve, the average fixed cost, is going to be decreasing. It's actually a hyperbola because we take a fixed amount and divide it by an ever-increasing number of units produced. So let's remember that. Fixed cost will be large when the production is small, because we have to attribute the whole amount of fixed cost to just several units produced. But they'll be decreasing as the output increases. So average fixed costs will be decreasing and fixed costs will be constant. What about variable costs? Well, variable costs are usually an increasing function of output. That means if you want to produce more, you need to hire more labor, and so your costs will be larger. Average variable costs, well, there is no rule about them, but usually we assume that average variable costs are also increasing because marginal cost of production are increasing as well. So with respect to variable costs and average variable costs, we should get two increasing functions where variable costs will increase fast. Average variable costs will not be increasing as fast because we're taking the blue line and dividing it by the number of units produced. So the standard assumption is that the average variable costs will be increasing. And now if we want to combine the average fixed costs and average variable costs on the same graph, well, the fixed costs, the blue line on this graph, it will be a decreasing function. Remember, we said that we take one amount and we divide it between an ever-increasing number of units produced. And the variable cost, the red line on this graph, will be an increasing function. So then the average total cost, being the sum of the two, will be a U-shaped function. It's going to be large for small values of output because average fixed costs are large when output is small, and then it's gonna get to some minimum level at one point, and then it will start increasing again because average variable costs are large when the level of output is large. So the yellow line on this graph is the average cost, and it's the sum of the blue line and the red line, and you can see that it's never low. Average fixed costs and average variable costs are sometimes low and sometimes high, but their sum is always relatively high. And that curve is U-shaped. And you can see that the graph just mimics the calculations for this particular example where, again, average total cost is the sum of the fixed and variable cost for every level of output. The interesting question, though, is what happens when we change the amount of fixed cost? What happens when the amount of capital in the story is increased or decreased? So suppose we started off with 90 and we're gonna increase the amount of capital to 120. Well, because we have more capital, the fixed cost, the cost that is independent of the level of output, is going to be higher. So with 120, the new fixed cost is going to be 120 no matter how much we're going to produce. Because fixed costs go up, average fixed costs are also going up because we're now dividing a larger amount by the number of units produced. So when it was 45, it's now 60. When it was 30, it's now 40, and so on. It's 100 over the quantity rather than 90 over the quantity, so the fixed costs have to be higher. So graphically, it's going to look like this. The blue line is the old level of fixed cost at 90. We raise the fixed cost to the new level of 120, and average fixed costs increase as well. So that is pretty straightforward. Hire more capital, pay more fixed costs, pay more fixed costs per unit of output. That's that. What about the variable cost? The standard assumption about the variable cost is that once we increase the amount of capital, variable costs should fall because labor should become more productive. That means with, I don't know, a better computer, a larger factory, every unit of labor that you hire should get more productive. Because otherwise, what's the point of hiring more capital? What's the point of renting more capital? So labor becomes more productive. That means that variable costs decrease. And so, for example, here, we started with variable cost of 10 and then got to 30 and 60. And now they've fallen at every level of output so that the new average variable costs fall as well. So graphically, it looks like this. Your old variable costs were the blue line. Now, for every level of output, so for example, for 4, they fall from 100 to 80 to the yellow line. So at every level they fall, so variable costs fall. And so average variable costs also fall. It used to be the red line, and now it's the green line. So two things happen when we increase the amount of capital used in production. Fixed costs go up, variable costs go down. What happens to the sum of the two? What happens to the average costs in general? The usual story is that average costs increase for small levels of output, but decrease for large levels of output. And let's see numerically and graphically how this works out. So the top row in the graph is the old average costs. The second and the third rows are the new average fixed and average variable costs. The fixed costs go up, average variable costs go down, and the sum is higher all the way to q equal to 6. You can say that it's 125 minus 125, which is larger than 100, 70 larger than 60, 55 larger than 50, and so on. And finally at 6, we get 55 versus 58. So graphically, it looks like that. The old average cost curve is the blue line, and it's lower than the red line. And you know that the new average costs are high for small levels of output because we have more capital, so more fixed cost and more average fixed cost. So the contribution of higher average fixed cost means higher average total cost at the small levels of output. But the contribution of lower variable cost means lower average cost when the output is high. So effectively, it's like we're taking our old average cost curve and shift it to the right. So at low levels, it's higher, at higher levels, it's lower. This is how it looks. Now, once we understand what happens to average costs in the short run, let's switch to the long run. Two takes. The short run average costs are U-shaped, and so here I'm extending the example to include output of 9, 10, and 11. And I'm looking at 3 levels of capital. Capital of 90, capital of 120, and capital of 150. So all 3 short-run average cost curves are U-shaped, and the higher the amount of capital that we're using, the higher the costs for small units of output and the lower the costs for large amounts of output. So we're shifting the line from blue, shifted to the right, we'll get something like red, shifted to the right even more, you get something like yellow. How do we get long-run costs from short-run costs? By answering the following question: what is the cheapest way to produce the given amount of output? For example, let's look at this graph. What is the cheapest way to produce 2 units of output? If we use capital 90, will be on the blue line, and the cost will be somewhere halfway between 150 and 100. The red line is going to be more expensive. With the yellow line, a capital of 150, it's going to be even more expensive. So the cheapest way to produce small levels of output is to use small level of capital, following the blue line. Now, once we get to 4, the cheapest way to produce becomes the red line, because the red line is now the lowest line among the 3 levels of capital that we're considering. Once we get almost all the way to 8, it's now the yellow line that is the lowest line, and so has the cheapest costs of output. So the answer simply is, for levels of output under 4, use the smallest level of capital, 90. Between 4 and 8, use the medium amount of capital, 120. For 8 and up, use 150. And this is exactly what the long-run average cost curve is about. Just pick the cheapest way to produce. So like underline the lowest curve on the graph. And I'm going to use color green for that. There we go. So the green line is comprised of the blue line from 0 to 4, the red line from 4 to 8, and the yellow line from 8 to 10. This is going to be the long-run average cost curve. It simply answers the question. In the long run, if you were to choose the level of capital, which level of capital should you choose depending on how much you're going to produce? This is what the long-run average cost curve is about. What do we know about it? Well, first of all, by the definition that I just gave you, the long-run average costs curve is the minimum of all possible short-run average costs curve for each level of output. Just consider all possible levels of capital that you can potentially have, and for a fixed amount of output, find the smallest cost. That is what the long run average costs curve is about. Graphically, it also looks like a U-shaped curve as in the short run. It's just that it incorporates all possible short run average cost curve. Finally, another thing that we need to know about the long run cost curve. We can break it into three regions. The region where the costs are decreasing, so the region where the slope is negative, the region where the costs are relatively the same, and the region where the costs are increasing. The first region with decreasing long-run average costs is called the increase in returns or economies of scale region. And so companies operating in this region decrease their per unit cost of production by increasing output. So returns to scale means if you want to produce more on a per unit basis, it's going to cost cheaper. The second region, where the costs are relatively constant, we call the constant costs, constant returns to scale. You want to scale up, you'll be paying the same price, more or less the same price per unit of output. And finally, the last region with the increase in cost is called decrease in returns to scale, because if you want to scale up in this last region, you'll have to pay more per unit. And the last important property about the long run average costs, we need to introduce the following definition, the minimum efficient scale. That is, we need to find the point or the points on the graph where the long run average costs are minimized and the smallest output at which we're producing at the minimum average cost possible is called the minimum efficient scale. Minimum efficient scale, smallest Q at which long run average costs are minimized. So it has to be somewhere in the constant costs region, somewhere here. Okay, remember the minimum efficient scale because we're going to use it in our next video. Thank you.